Now we'll take a look at transitive reasoning, where we're going, direct reasoning was if P, then Q. Now we're going to add a few more steps. So this leads us to the law of syllogism or transitive reasoning. And basically, it starts with the same beginning. If P, then Q. If I'm standing in P, then I have to be in Q. But then it says, wait a second. Q could be in something else called R. It could be the hypothesis of another conclusion. So if I'm standing in Q, then I have to be in R. So if that's the case, if I'm standing in P, do I have to be in R? Yes, I do, because P's in Q and Q is in R. That is the law of syllogism or transitive reasoning, where you take if this, then that, then if that, then something else, and if something else, then another thing altogether. And this all comes together quite funnily, and if you can say that word, in one of my favorite commercials, which you're about to enjoy.
When you wait forever for the cable guy, you get bored. When you get bored, you start staring out windows. When you start staring out windows, you see things you shouldn't see. When you see things you shouldn't see, you need to vanish. When you need to vanish, you fake your own death. When you fake your own death, you dye your eyebrows. And when you dye your eyebrows, you attend your own funeral as a guy named Phil Shifley. Don't attend your own funeral as a guy named Phil Shifley. Get rid of cable.
So essentially, you start out by seeing something you shouldn't see, and it all started because you had cable. And that was your P, then Q. And then it keeps going on and on. So the law of syllogism is talking about a train of reasoning. Now, how are we going to determine if a conjecture is valid? You can use this law of syllogism. And remember that if anything is given, it is assumed to be true. So in this example, it is given that if all sides of a triangle are congruent, then it is equilateral. So one of the things I'm going to do is identify the P and the Q here. So it's saying this statement, if all sides of a triangle are congruent, then equilateral is true. If sides are congruent, equilateral is true. Okay? Then it says if it's equilateral, then all angles are acute. Well, I shouldn't use P here because I use that for sides. This is actually the Q from the previous sentence. And then I need something new for this new conclusion, which I'll call R. So Q, then R is true. Now, so it says, if I'm in P, then I'm in Q. That's true. And if I'm in Q, then I'm in R. That's true. But it's not going to tell me if I'm in P or Q yet. All it told me is that all angles of a triangle are acute. It said R is true. Well, you can't really go backwards in using the law of syllogism. You can only go from P to Q and Q to R. But you can't go R to Q and Q to P. So this is actually invalid. You cannot go backwards from R to Q. Let me show you this a different way with a Venn diagram. So what the problem said is it said all sides are congruent of a triangle. Just assume the triangle's there. All right? And if all sides are congruent, then it's equilateral. So if I'm in here, I have to be in the group of equilateral triangles. And that makes sense, all right, for a triangle. Then it said if I'm an equilateral triangle, then all my angles are acute. And that actually makes sense too, all right? But what it told me was that all angles are acute. So that means I'm in R here. Does that mean that it has to be an equilateral triangle? No, it could be a 20, 80 degree triangle. And that would be all angles acute, but definitely not equilateral. So just because all angles are acute doesn't mean it's equilateral. So it's an invalid argument. Now you're probably not going to have to say, oh, this is invalid because of the transitive reasoning or even direct reasoning. You just need to be able to use the reasoning to determine if an argument is valid. Now, also the other ways you're going to be using deductive reasoning is always assume that definitions, axioms, postulates, and properties are true. Assume anything that is given is true for that specific problem. That doesn't mean it's true for forever and for all time. Also, you can assume the following is true on diagrams. Like if points look like they're on the same line, then they are collinear. If a point looks like it's between 2 points, then they are between. If points look like they're on the same plane, then they are on the same plane. Straight angles, which are 180-degree angles, are 180, and straight lines are straight. Do not assume that a line's gently bending. Adjacent angles, if they're touching, they are touching. And if two angles form a linear pair, you know, where it's like 180, they form a line, then they do. And vertical angles are these angles. If they cross, they are vertical angles. You cannot assume the following is true on diagrams. For example, the measures of segments. Don't go getting a ruler and measuring something. We normally don't do that kind of problem unless it's a special scale drawing. Don't assume measures of angles. So if we draw a picture and it looks like it's acute, it could actually be obtuse. Or if it looks obtuse, it could be acute. Don't assume that it's right just because it looks close to being a right angle. Don't assume that segments are congruent if there is not a congruent mark there. And don't assume that angles are congruent if there is not a congruent mark there. And again, right angles, just because it looks like it's 90, unless it has that little square in it, do not assume that it is a right angle. So finally, for further reflection, what is the law of syllogism or transitive reasoning, and how does it work? And what are some things you can assume are true from the figures, and what can you not assume to be true?